RCA Selectavision Videodisc. To the average consumer, it begins right here with a player, a TV receiver, and a CED video disc like this one. To the people behind the scenes, the people at RCA, it begins with raw materials as pure as those used in medicines, plus a myriad of parts and procedures. For some, it's this master videotape. For others, a disc begins with a stamper, the actual device which presses the disc. Actually, a finished disc begins with these pellets. One RCA video disc equals about 2 cups worth. And one finished RCA video disc player equals several thousand individual components and parts like these. And every component and part must be ordered, inspected, inserted, and assembled before inserting this disc into this player can produce the great home entertainment and information consumers expect it to deliver. And deliver it does. Over 96% of surveyed RCA video disc owners say the Selectavision system is everything they expected it to be. Well, with that kind of expression of confidence in the quality and capabilities of this still new consumer product, it's no wonder the average purchaser of this player is also buying from 20 to 30 of these discs in the very first year of ownership. Well, in the next few minutes, we'll see how it all comes together. Now, we'll follow the disc production process here at RCA Selectavision facility in Indianapolis, and then we'll tour RCA's player assembly facility in Bloomington, Indiana. You'll understand the reason for this lab coat in a moment. It's required dress if we're going to witness how the television information on this master 1-inch videotape is transformed to the 12 miles of grooves cut into this copper video disc master. We're now entering the environmentally controlled area where all RCA video disc production takes place. See, this lab coat and cap help keep foreign particles like lint and dust to a minimum. Our master videotape has gone to mastering control, and we'll catch up with it in a moment. Right now, we have to prepare the copper master. Now, it actually begins as this polished aluminum plate. But when it arrives in this room, the copper coating has already been plated over it. Now, the surface must be as perfect as possible, smooth, flat, and defect-free. A special barcode is added first. A similar code, like the ones you see on grocery products, is printed on the label of the disc caddy. Thank you. From this point on, this master is destined to carry a specific video disc program like the one waiting for us on tape in mastering control. As a final check, our copper surface is scanned by a laser for detection of any microscopic defects. And once the master passes this inspection, it is numbered and coded. Thank you. The mask prevents any breath moisture or a sneeze from landing on the copper surface. Now it's on to mastering control. Our master is being set up next door here in the cutting room. In the next few moments, the master recording will be cut. This control board tracks the program audio response. Now, if a little sweetening is required, it can be done right here. Stereo, noise reduction, and dual soundtrack or bilingual audio is also processed through this control unit. Now, program video is also monitored at all times, both visually and electronically. The master cutting has now started. This lathe is recording a frequency modulated or FM signal. Its diamond cutter is moving up and down 3 million times every second as it traces out that signal. And this is what's left over. 12 miles of continuous copper filament finer than the finest thread. Well, by the way, the lathes are mounted on a floating suspension system. Just the slightest seismic disturbance could alter the signal cutting process. To give you an idea of the dimensions we're talking about, here's a groove mock-up 10,000 times actual size. These are the undulations of the signal the cutter is vibrating 3 million times a second to produce. The player's stylus rides in the groove and reads the signal as it passes over the peaks and valleys. In contrast to this, which recreates 10 video disc grooves, one groove in an audio record would be about, well, the length of this entire table. The next process in video disc production creates a stamper for the pressing of finished video discs. First, our recorded copper is used as a form for making what is called a master. Then a mother or mold is formed from the master. And finally, the stamper for the press is formed from the mold. This process is called electrodeposition. Now, these nickel pellets are dissolved in a special solution and then formed onto the submaster as it spins in the bath. The stamper is then separated from the mold. Another critical operation calls for precise centering of the stamper and the punching of the center hole. The finished disc must rotate as a virtually perfect circle. Our stamper is now ready for the press. This is the press room. Our stamper and its companion side are now producing one disc every 40 seconds. Now, this shield helps create a controlled environment. Filtered air is circulated down from the top through vents in the floor. The pellets, which make up the disc material, are automatically fed from the compounding room to this hopper. Then they're formed into shots, like this one. A heated shot is then fed into the press for stamping. The pressed disc is then automatically cooled, trimmed, and spindled. Sample discs are pulled regularly for quality control testing. Special playback units measure signal-to-noise ratios, count any defects, and rapid scan the recorded program to evaluate overall quality. If tested discs don't measure up, the entire press run will not arrive here, where both sides of each disc are inspected for any obvious surface flaws. Discs that pass are now conveyed through a series of washes and rinses, followed by a final rinse to expedite fast drying. When they reach this point, they're only seconds away from meeting up with this. Disc caddies must be prepared and labeled long before the discs that go into them receive their final rinses. The spine and the two halves of the caddy are cleaned before they enter the assembly line. Special strips are applied. They provide a dust seal and also clean the disc each time it's loaded and unloaded. The two sides are ultrasonically welded together and then checked for disc and spine clearance. Now, the spine is what interacts with the disc player's load and unload mechanism. It stays with the disc inside the player. Well, our caddy now needs a label. It's automatically fed onto this machine and aligned by electronic eyes directly over a pre-glued label. From There, it's a quick drop through a special wrapping mechanism that folds and bonds the label to the caddy. Our caddy, complete with its new label, is now ready for a disc, just like that. Now, labeled caddies are cataloged and stored until it's time for insertion of the disc press run. Right before caddy insertion, each disc is given a fine coating of oil on both sides to prevent stylus wear during playback. The disc is then lifted from the conveyor and placed onto the spine. And the barcode on the disc is read to be sure it matches the one on the caddy. Insertion is now complete, and our finished RCA Selectavision video disc is ready for its shrink wrap. If it's a 2-disc album, the second disc meets the first one here. The 2 discs are then automatically wrapped together and labeled stereo if they need to be. Well, from here on, it's on to packaging, inventory, and order fulfillment. Some of the discs will make a separate trip through this product evaluation station. It's a final stage to help assure that the product the consumer receives measures up to RCA's quality standards. Now, the discs that are tested here must be passed before the packed and palleted press run can be accepted for order fulfillment. When RCA Selectavision video discs enter this area, they've passed from an environmentally controlled manufacturing system to a computer-controlled inventory, fulfillment, and distribution system. Every accepted pallet of discs is logged in by this computer moments after arrival. It can respond with a specific shipping order printout almost instantaneously. As soon as discs are in inventory and orders are verified, the computer feeds the warehouse printer a complete shipping order. Short orders, or small quantities of 10 or less, are picked from this opened inventory and then conveyed to a packing station where the order is double-checked. Once the order is strapped for protection, it's ready for pickup, usually by UPS. Quantity orders are filled by the pallet and wrapped securely on this special turntable. From here, it's a final check by the common carrier driver and a quick trip into the distribution pipeline. The ultimate destination is, of course, right here, inside an RCA video disc player. As the old song about love and marriage says, you can't have one without the other. Here's our spine, the disc, and here's the tracking arm which carries the player's diamond stylus. Now, here's how the arm looks before it goes into the player. And here's how the player looks before it becomes one. Thousands of diodes, resistors, and other component parts, including some of the most sophisticated microcomputer chips available today. And they all come together looking like this: the RCA Selectavision video disc player. Now, the random access model has the capability of finding any one of several thousand images recorded on our disc. It even generates a time display on the TV screen, plus additional graphics. And of course, it has to translate these groove undulations into a television signal, as well as into direct video and sometimes stereo audio signals. Remote control commands from this infrared hand unit must also be processed by the player, and the response must be instantaneous, which is why every diode and transistor is 100% tested before entering the player assembly area. Heat and cold stress tests make sure they measure up. Other tests check the geography of prefabricated parts. You see, every screw hole and assembly point must be in perfect alignment to ensure precision player operation. After inspection, individual components are automatically sorted onto a special tape reel. They have been placed in an exact order because in a few moments they will be automatically inserted into this master signal processing board. It looks, reads, and is like an electronic road map. This machine is shaking these metal stakes into special positioning posts. The posts will then insert the stakes into specific slots on the board. Now, these stakes will serve as connector posts during the player build-up process. Once staked and riveted, our board goes to automatic insertion. This machine automatically places each component in its proper position. Now, once automatic insertion is complete, the boards are racked and then sent to the circuit board build-up line. Each station is responsible for the addition of specific components to the board. The next step is to secure them to the board. To do this, each board passes over a bath of liquid solder, which bonds the component leads to the board's metallic patterns. The end result looks like this, with all these components now fully integrated onto the board. And after just a few more steps, board buildup will be complete. Which means our master circuit board is now ready for its final pre-player assembly test and alignment. Any imperfection or faulty component detected here will send the board to a special troubleshooting station for closer examination. Boards that pass are now ready for the final player assembly process. We are now beginning tracking arm buildup. Now, the arm assembly is die-cast zinc. This precision boring device is making sure the assembly's fastening holes are exactly aligned. You see, the arm is a very complex device. It must house not only the stylus cartridge, but also the sensitive pickup electronics. When the arm reaches this final testing station, over 80 distinct components on 3 subsystem circuit boards have been assembled into it. Thank you. Now, this too is ready for final player assembly, along with our master signal processing board. The player's direct drive turntable is the last major component that we need. Now, you see, this ring on the bottom of the turntable will actually become a component of the motor. The turntable must spin at precisely 450 revolutions per minute on a perfectly flat plane, so balance is critical. This operation dynamically checks and adjusts that balance. Now our turntable is ready to make its way to the final assembly line. Here it joins forces with the master processing board and the pickup arm. The turntable will be magnetized to allow it to operate with the motor drive system. Then its height must be set. The automatic loading mechanism must be assembled and the power transformer added. Not to forget this very essential power cord. Now, this final line procedure is called stop station assembly. You see, total player production is dependent on the speed of the slowest process on the line. Now, the player is conveyed on this special table with its own power outlet. This enables each player to be tested at several points during assembly. This troubleshooting station keeps a running log of any problems. The information gathered here can also be used to track performance standard trends. If a certain tolerance begins to waver, it may be time to make an adjustment at a previous production stage. Life tests are conducted separately. Sample players are taken from the line and brought to this room and subjected to 500 hours of continuous play. Well, this helps assure that all the components and parts will perform at the optimum levels expected of them. Each player's final quality check is conducted in this shielded room at the end of the stop station line. Color quality, picture stability, and of course, audio performance are all monitored here. With the next and final procedure taking place right below. These are the finishing touches: the cover, the special labels, and the packing tabs. And of course, the owner's manual. And finally, the finished product, ready for shipping through the distribution pipeline. Some players, however, are in for a not too pleasant side trip. These two, for example, are about to be dropped. After a couple more hard knocks, the player is checked to see if it withstood the abuse. Well, it may not seem like a fair test, but it's an essential one. You see, an instrument like this, with the capability to retrieve and play back video and audio information stored on a device like this, must be designed, engineered, and manufactured to perform for consumers like no system they've ever seen before. And RCA has to be confident it will work as soon as it's removed from the carton and properly connected. To the average consumer, this is how it all begins. To the people at RCA, who you've just seen working to bring it all together, this is just about where the whole process ends.